Welcome to the second video in the series of how to work with powers and units. In the first video, we covered how to resolve powers using the index laws. In this video, I'm going to approach the same question, but consider only the units. Again, remind yourself that we have this equation that's going to help us resolve this question. Remember last time that what we did was we took all the values or numbers and we substituted them into the equation. We're going to do the same thing this time, but with the units. So allow me to just write it out again for you. R equals mass times velocity divided by charge times the strength of the field. Now, with the units, so the units of the mass are in kilograms, so we can substitute that in, times the units of velocity are meters per second, divided by the units of charge are coulombs, C, times the units of the strength of the magnetic field are Teslas, T. Now there are 2 points I want to make about this equation that we see here with these units substituted in before we move on. The first one is that it's often easier to not express your units, such as this meters per second is expressed with a slash. Okay. Instead, what we want to do is we want to utilize one of the other index laws that we have that states that 1 over anything, so let's call x, is the same as x to the negative 1. That is to say, a negative index represents a 1 over. Okay, so for this meters per second, what we can actually do is we can write this as meters seconds inverse. Okay, and this is a much better format. It's clearer and it's going to enable us to easily compare and cancel the units in later steps. Okay, so I encourage you, whenever that you can see units that have been expressed with this slash or over sign, to convert it into a negative index like shown. The second point I want to make is regarding the units in the denominator of this equation, coulombs and Teslas. Now, coulombs and Teslas are specific units that represent charge and strengths of fields. Okay. Now, the problem is we can't resolve these with kilograms and meters and seconds as they are. Okay. However, what we know is that these can be expressed in terms of the SI base units. Okay, so SI base units. If you don't know what SI base units are, or if you haven't encountered SI base units before, please watch the video that we have on those. Knowing this, what we can actually do is we can re-express these in terms of those SI base units. So coulombs is the same as amperes per second, and Teslas is the same as kilograms times amperes to the negative 1 times seconds to the negative 2. Knowing this, we can substitute these into this equation here to re-express C and T. So I might write it over this way. So we actually got now kg times meters seconds inverse on A times S times kilograms A inverse seconds to negative 2. From here, the way to resolve this is once again to use the index laws that we discussed. The critical one here is the division index law. I would remind you that that states that the division of two values that have the same base but a different power will result in that base with the difference of those powers. Okay, so we can apply this to this. Now, very quickly, the kilograms are both kilogram to the power of 1. So 1 minus 1 is 0, so these kilograms are actually just going to cancel straight out. Okay? Now, this meters is the only meters in this whole fraction, so that's going to stay as it is. Now the seconds to the negative 1 is going to cancel with the seconds on the bottom here, okay? To find out how many seconds in total are on the bottom here, we use that first index law that was discussed, which is that the multiplication of two values with the same base but different powers is that base with the sum of the powers. So s times s to the negative 2 is s to the 1 plus negative 2, which is s to the negative 1. And that s to the negative 1 is going to cancel straight off with that s to the negative 1 on top. And with this amperes, here we have amperes to the 1, amperes to the negative 1. So 1 plus negative 1 is 0, a to the 0, anything to the 0 is 1. So that will cancel out as well. So this meters is the only thing we're left with. So the overall units of this equation is simply meters. Now that unit makes sense in light of what the question has asked us to find the radius. So radius is a measure of distance, so we'd expect it to have units something similar to meters. The problem is that many students will assume what the units of the answer are and not include any of the unit analysis in their working out. This is wrong, and you'll lose marks for it because it's not a good example of how to work out and set your working out clearly.